Okay, think about this. 3.6 billion years of life on Earth. And for almost all of that time, evolution just ticked along slowly. But then, somehow, in just the last 40,000 years or so, human genetic evolution accelerated like crazy, more than 100-fold. And our impact? Well, it's become so huge, scientists have actually named a whole geological epoch after us, the Anthropocene. It's kind of mind-blowing, really. Welcome to the Deep Dive. We explore the big questions about what makes us human, and today we're diving into exactly how human evolution suddenly hit the accelerator. Turns out, it wasn't just biology. The secret ingredient, the thing that makes us unique, seems to be culture. So this deep dive is all about unpacking how culture shaped, well, everything, our brains, how we live together, and yeah, the entire planet. We'll be focusing especially on that huge turning point, agriculture. Our mission, as always, is to pull out the key insights from the research you've sent us. We want to help you understand the why behind our incredible journey and also some of the unexpected twists and turns that came with our biggest innovations. Right. Let's try and speed through billions of years. Just to set the scene for our story, for almost all of life's history, and 99.9% of our own ancestors' time, adaptation was just biological, slow, steady change. But then things really started shifting. The sources talk about 3 distinct ages of adaptation.
Yeah, and what's really fascinating, just jumping in, is the sheer speed increase, the acceleration. We started off in that first age, purely biological evolution, like every other creature out there. Then we entered the second phase, what the research calls gene-culture co-evolution. Think maybe the last 2 to 4 million years. This is where it gets interesting. Our cultural stuff, making tools, maybe controlling fire, how we found food, started creating new challenges. And our bodies, our genes, started adapting in response to those cultural pressures. And that interaction, that feedback loop, is what apparently sped up our genetic evolution so dramatically, over 100 times faster in the last 40,000 years. And it made our physical changes, our morphology, evolve faster than other mammals too.
100 times faster. That's staggering. So where does that put us now? Are we still in that co-evolution phase?
Not really, no. We're now solidly in what the sources call the third age, and here, cultural evolution just completely takes over. We basically solve problems using culture, technology, knowledge, social organization, way faster than our genes can even begin to respond. Think about it. Just 10,000, maybe 12,000 years ago, our ancestors lived in ways not that different from chimps in some respects. And now, we split atoms, build megacities, have the internet, we've walked on the moon. The pace is just incredible.
But that speed must have consequences, right? It can't all be smooth sailing.
Absolutely. That's the crux of it. Our culture lets us adapt incredibly quickly, which is amazing for us in many ways. But it also means we transform the planet at breakneck speed. And that impact is so profound, that's why scientists coined the term Anthropocene, the age of humans. We're literally changing the rocks, the climate, the ecosystems. And the downside, a huge number of other species they can't keep up. They can't evolve fast enough through natural selection to cope with the rapid changes we cause. So they face extinction. It's a really sobering thought.
Okay, so culture is the key driver. But how did it start having such a fundamental effect? How did it get tangled up with our biology, our brains?
Well, the sources really connect it back to basics, food and brain power. Early cultural tricks were essentially survival hacks passed down through learning. How to find better food, more nutrient-dense stuff, how to make simple tools to cut or process it, how to maybe use fire. These things made getting energy more efficient, like adding more meat to the diet that's a concentrated energy source, and later cooking food that dramatically reduces how much energy your gut needs to digest it.
Okay, so we're saving energy on digestion.
Well,
That saved energy had somewhere to go.
Exactly. It went to our heads, literally. Our brains are incredibly greedy organs. They use about 20% of our daily energy, even though they're only, 2% of our body weight?
Yeah.
So getting more energy more efficiently was crucial, but it also created this need to get even more calories to fuel those growing brains. It becomes a feedback loop, you see. Being smarter helps you get more food. More food supports a bigger brain. A bigger brain allows for more innovation, better social learning, and the cycle continues.
That makes sense. Smarter foraging, better tools, maybe cooperation, all leading to more brain fuel.
And connecting that to the bigger picture again, this efficiency didn't just boost brain size. It allowed our populations to grow. Human numbers stayed pretty low for a very long time, but they really started to climb and then exploded after agriculture came along. That's how we eventually came to dominate ecosystems. Every big invention since animal domestication, irrigation, later biotechnology increases food production, allows the population to expand further, and that, in turn, creates even faster rates of cultural change. More people means more ideas.
And it highlights just how dependent we became on learning from each other, this socially transmitted knowledge for basic survival. The sources say this dependency led to all those features we see in human culture today. Huge amounts of knowledge, keeping that knowledge over generations, even things like trends and fads, and of course, rapid technological change. Okay, but if cultural evolution has this built-in accelerator, why the incredibly long period as hunter-gatherers? Billions of years, then millions as hominins, then hundreds of thousands as Homo sapiens, mostly hunting and gathering. And why do some groups still have relatively simple tech today?
Right, that's a really important question. It seems paradoxical, doesn't it? The research points to a kind of, well, I call it a vicious cycle that kept things slow for a long time.
A vicious cycle. Yeah. How so?
Well, think about how much knowledge is needed, even for seemingly simple hunter-gatherer life. Take honey gathering. Among the Hadza in Tanzania, for instance, honey is like 15% of their diet. It's crucial. But getting it involves a huge amount of learned information. You need to know which bees are safe, some are stingless, others are, African killer bees, very dangerous. You need to recognize their nests, know where to look, how to climb trees safely. They even use special techniques like hammering sharpened sticks into the trunk to make a kind of ladder. Then you need to know how to build a fire, use the smoke to calm the bees, how to safely remove the nest, extract the honey. Some groups even learn to communicate with a specific bird, the honey guide, that leads them to hives. It's this whole complex body of knowledge.
Wow, that's definitely not simple. It's a whole curriculum just for honey. So what does that dependence on knowledge combined with their lifestyle mean for the pace of change?
It means constraints. Big ones. Nomadic hunter-gatherer groups are always on the move, right? Following game, finding ripe plants. You move camp every few days or weeks. That means you simply can't carry much stuff. Your toolkit has to be portable. Forget about storing food long-term. And crucially, it limits population density and growth. A mother carrying a child plus foraging gear can really only manage one dependent infant at a time. You see this reflected in birth spacing, like the Kung San, traditionally spacing births about 4 years apart. Keeps population sizes small.
Okay, so small groups, constantly moving, limited gear. What about the social side?
Well, in many of these societies, almost everyone does the same job. Finding food, there's not much specialization. That leads to fairly simple social structures, generally quite egalitarian, without much chance to accumulate wealth or possessions. So you've got this combination. Small population, limited contact between groups maybe, everyone busy foraging, not much surplus time or energy, few specialists. It all adds up to fewer opportunities for innovation and slower spread of new ideas. They were essentially, as the sources say, kind of trapped by the demands of their environment and lifestyle.
Trapped, but not forever.
Yeah.
Eventually, something broke that cycle. The sources talk about reaching a critical threshold.
Exactly. New technologies, new knowledge allowed some groups to exploit their environments much more efficiently. And that changed everything. And the big one, the one that really represents crossing that threshold in many places, was agriculture.
Agriculture, the game changer.
Absolutely. The consequences were immediate and just cascaded outwards. Once you start farming, you tend to stay put. You become sedentary. Suddenly, you can store food. You can accumulate heavier, more complex tools and equipment. You start building permanent structures. Having a bigger toolkit means more bits and pieces you can combine in new ways. Tinkering becomes easier. Being settled also means women don't face the same constraints on child rearing. Birth spacing can reduce. Populations start growing much faster. And more people means more potential innovators. Plus, with stored food, maybe some people have more time and resources to innovate.
So it's really clear, looking at the research, that the acceleration of cultural evolution took off like a rocket with agriculture. It broke those shackles of nomadism.
Definitely. And what's also fascinating, connecting to the bigger picture, is that it wasn't a one-off invention. Agriculture popped up independently in at least 8 different places around the world. The Fertile Crescent, sure, but also Mexico, China, the Andes, maybe New Guinea. Now, climate change played a role. The end of the last ice age, around 11,500 years ago, brought the warmer, wetter, more stable conditions of the Holocene. That was likely necessary. But climate change wasn't the direct cause. The key idea from the sources is that humans didn't just stumble into farming. They actively constructed the agricultural niche.
Constructed it. So we weren't just passive recipients. We made it happen.
Yeah, through countless small, cumulative cultural practices passed down over generations. Things like selectively gathering seeds from the best plants, deliberately planting them, clearing land by burning, maybe tilling the soil with digging sticks, developing simple irrigation, even creating fertile patches through waste disposal, those dump heaps. These were all learned skills, and they led to this amazing coevolutionary process.
Coevolution between us and the plants and animals.
Exactly. Think about wheat. Wild wheat shatters easily to spread its seeds. Domesticated wheat holds onto its seeds, making harvesting easier for us, but making it dependent on us for propagation. Many domesticated plants, like modern bread wheat, which is polyploid, meaning it has multiple sets of chromosomes, became much larger, higher yielding, ripened predictably, but completely reliant on humans. Same with animals, cattle, sheep, goats. They evolved traits that suited us, but often made them less able to survive in the wild. And this domestication process often started slowly, thousands of years before what we'd call full-blown agriculture. There was this long transitional window where people were experimenting, managing plants and animals, but still relying heavily on wild resources too. Having the right kind of plants available was also key. Things like annual grasses with big seeds, the ancestors of rye, wheat, barley, rice, maize, were much easier to domesticate than, say, oak trees.
Okay, so agriculture sounds like this massive success story for humanity. More food, bigger populations leads to cities, technology, but the sources paint a more complex picture, calling it a double-edged sword.
Yeah, that's a really crucial point because counterintuitively, perhaps, the shift to agriculture often led to a decline in health, at least initially for many people.
A decline? But they had more food, didn't they?
They often had more food overall, yes, but maybe less varied food. Diets narrowed, relying heavily on staple crops like grains. And the archaeological evidence, the skeletons, show increases in problems. More signs of infectious diseases, things like tuberculosis or leprosy, jumped from domesticated animals to humans living closely packed together with livestock and waste. Zoonotic diseases, they're called. Dental health plummeted. Lots more cavities and enamel defects from diets high in carbohydrates and sugars from grains. There's even evidence that people got shorter for a while in Europe. Between about 2,300 and 400 years ago, average male height actually dropped by around 7 centimeters. That's a pretty strong sign of nutritional stress, probably outside the elite groups.
Wow. So worse health, harder work probably, higher risk of crop failure. Why on earth did people adopt it then? Why stick with it?
It's a puzzle, isn't it? The sources suggest two main reasons why agriculture, despite its drawbacks, ultimately won out. First, and this is huge, it allowed for a massive increase in the number of people an area of land could support. The carrying capacity of the environment just skyrocketed.
Okay, so even if individuals weren't necessarily healthier or happier, there were just more of them.
Exactly. If you connect that to the bigger picture, farming societies could simply out-reproduce hunter-gatherer groups in the same area. Individual survival rates might have even dipped slightly, but the sheer number of children surviving to adulthood increased dramatically because you could feed more mouths, and sedentary life reduced birth spacing. The global population figures tell the story. Maybe around 1 million people before agriculture jumps to over 60 million by the time of the Roman Empire. And genetic studies confirm these huge population expansions radiating out from agricultural centers. It was a numbers game, and agriculture won.
Right, the demographic advantage. What was the second big factor driving its adoption and spread?
The second factor is that agriculture wasn't just one innovation. It was what the researchers call a key innovation, one that unlocks a whole cascade of further innovations.
Okay, so it created demand for other new things.
Yes. Suddenly, tools like spades, sickles, and especially plows became incredibly valuable. You needed better ways to store grain, so pottery and granaries became essential. Irrigation systems were needed in many areas. Stronger building materials for permanent houses, draft animals to pull plows, looms for weaving textiles from cultivated fibers like flax or cotton. It also fundamentally changed society. You needed organized labor for big projects like clearing land or building irrigation canals. You saw the rise of specialization. Not everyone was a farmer anymore. Think of Adam Smith's famous example of the pin factory. One person working alone could barely make 20 pins a day, but 17 people specializing in different steps could churn out 4,800. That kind of division of labor really took off with agriculture. And with surplus food and stored wealth came social stratification hierarchies, rulers, priests, warriors, artisans, and even, weirdly, new niches for other creatures like cats to control rodents and granaries, but also for rats, mice, and weeds that thrived in disturbed agricultural landscapes.
Let's dig into some of those follow-on innovations. The plow seems like a really fundamental one.
Oh, absolutely. It started simply maybe just modifying a digging stick to break up the soil a bit better. Then came hoes and eventually simple scratch plows, basically just wooden frames that scratched a furrow pulled by humans or maybe oxen. We see evidence of these early plows in places like Mesopotamia and the Indus Valley as far back as 6000 BCE. The Egyptians were real innovators here. They developed more sophisticated designs, some that could lift and turn the soil better, and crucially, they combined them with large-scale, complex irrigation systems needed for the Nile Valley. Later, the Greeks took those designs and improved them further, notably by adding wheels. That gave much better control and stability. Even if they didn't invent the wheel itself, they integrated it brilliantly.
And thinking about adapting to difficult environments, the Incas in the Andes, farming on steep mountainsides seems almost impossible.
Right. Their solution was incredible ingenuity. Terrace farming. Machu Picchu is the famous example. These weren't just flattened steps. They were complex constructions designed to manage water-draining rainfall, preventing erosion, stabilize the soil, and create level platforms for crops like maize and potatoes at high altitudes. It required sophisticated engineering, building these retaining walls, filling them with soil, and creating intricate channel and aqueduct systems to bring water where it was needed. Truly remarkable.
It really underscores how vital water management became alongside agriculture.
Indispensable, especially in drier regions. Early Mesopotamian cities were essentially built around their local irrigation networks. They couldn't have existed otherwise. Same for the Greeks and Romans in the Mediterranean climate. Controlling water was fundamental to their agricultural success and therefore their civilizations.
And it wasn't just practical tools and techniques. Agriculture seeped into the very belief systems of these societies, didn't it?
Deeply. You see it reflected in their gods. The Incas worshipped Inti, the sun god, who was also intrinsically linked to agriculture vital for growing crops. The Egyptians had Renudet, a cobra-headed goddess associated with the harvest, nourishment, and protection of granaries. The Greeks had Demeter, goddess of the harvest and agriculture, who supposedly gave wheat to humankind. The Romans had Ceres, her equivalent, credited with discovering grain and inventing the plow. Countless rituals, festivals, ceremonies revolved around pleasing these deities to ensure fertile fields and abundant harvests. Agriculture was central to their worldview.
Beyond farming tech, you mentioned other key innovations sparking cascades. The wheel is a classic example.
Yes, the wheel is fascinating. Its earliest known use wasn't actually for transport, but possibly on sledges or rollers, and then quite early on as the potter's wheel in Mesopotamia, a huge boon for craft production. Then came carts and wagons, war chariots, wheels used for grinding grain, and pulley systems for lifting heavy loads, eventually in things like spinning wheels for textiles. A major leap was the invention of the spoked wheel, around 2000 BCE, probably somewhere in western Siberia or the Near East. This made wheels much lighter and stronger, allowing for fast, maneuverable chariots that revolutionized warfare, but also impacted travel and even sport. And think about horse domestication, often associated with groups like the Scythians on the Eurasian steppe. Combining horses with wheeled vehicles, or just riding them, transformed mobility in warfare. It even apparently gave rise to the Greek legend of the centaur riders seeming fused with their horses.
So fast forward to today. We've gone from a few hundred types of tools to, like you said, New Yorkers can choose from 100 billion barcoded items. That's just impossible to grasp.
It is. Innovation is now professionalized. It's often driven less by fundamental needs and more by perceived wants, by market demands, by planned obsolescence sometimes. And while modern medicine is obviously a huge benefit, improving quality of life, many modern innovations don't really impact our basic biological fitness or survival and reproduction in the same way early innovations did. Now, fitness can sometimes seem more about cultural success, like how viral something goes on social media.
But innovation isn't always successful, right? For every iPhone, there are probably dozens of flops.
Oh, absolutely. The sources mention some classic examples. Remember New Coke, a spectacular marketing failure, or the Sinclair C5, that little electric tricycle, didn't quite catch on. Sometimes even technically good products fail because of market dynamics or conformity. Sony's Betamax video format was arguably better than VHS, but VHS won the standards war. Same with HD DVD versus Blu-ray more recently. And then there are just weird inventions. Cheese-flavored cigarettes, apparently, or those phone fingers, little latex tips so you don't smudge your screen. Success isn't just about merit. It involves timing, marketing, network effects, and, yeah, quite a bit of luck.
Okay, so bringing this all together, we started by talking about the incredible speed-up of cultural evolution, the Anthropocene, and how agriculture was this pivotal moment. But the sources end on a rather stark note, emphasizing that double-edged sword idea. Agriculture wasn't just a beginning. It was also perhaps the opening of Pandora's box.
Yes, that's a powerful way the sources put it. While agriculture gave us this incredible food surplus, fueled population growth, and led to complex societies, it also seems to have kicked off what they term a disconcertingly long history of biodiversity destruction. Even before agriculture fully took hold as humans spread across the globe, there were massive extinction events. Between about 50,000 and 10,000 years ago, something like 101 out of 150 genera of megafauna woolly mammoths, giant sloths, saber-toothed cats disappeared, and humans definitely played a significant role alongside climate change. Later, the expansion of Polynesian peoples across the Pacific Islands led to the extinction of thousands of unique endemic bird species and other animals. Agriculture just intensified the pressure on landscapes.
And that pressure continues today. The sources point out the irony that the Fertile Crescent, the very birthplace of agriculture, is now suffering terribly from habitat loss, desertification, overexploitation of resources.
Exactly. We're essentially undermining the very biodiversity that made agriculture possible in the first place. It's a profound contradiction.
So connecting this to the present day.
The innovation society we live in tends to believe that technology solves problems, and it often does, creating huge benefits. But the lesson from agriculture and subsequent innovations is that every solution potentially creates new problems. Think about modern food production again. Incredible abundance and variety for many, yes. But it's also given us an oversupply of cheap, highly processed, high-calorie foods, which is fueling epidemics of obesity, diabetes, heart disease. And while agriculture enabled complex societies, it also laid the groundwork for massive social and economic inequality. That gap between the richest and poorest, both within and between nations, is still a defining feature of the modern world, and in many ways, it's widening.
So it's been quite a journey. Billions of years, the unique role of culture boosting our evolution, and then agriculture dramatically changing our societies, our health, and the planet itself.
Yeah, we've traced how that incredible adaptability from culture, especially turbocharged by agriculture, allowed us to spread and dominate. We saw the cascade of innovations that unleashed the plow, the wheel, writing cities, right up to the digital age. But we also saw the hidden costs, the initial health declines, the deep social inequalities, and this relentless environmental impact that started way back then and defines the Anthropocene today.
It really highlights just how intertwined our culture, our biology, and the fate of the planet have become. They're inseparable.
Which leaves us, and you, the listener, with a pretty big question to think about. If we know that innovation, historically, tends to create new niches and new problems even as it solves old ones, how can we consciously use our amazing human capacity for high-fidelity social learning, for building cumulative culture, to design innovations now that genuinely tackle the huge problems of the Anthropocene, climate change, biodiversity loss, inequality, without inadvertently making things worse or just creating a different set of problems down the line? Can we